Hey everyone, my name is Keith Horwood, and today I'm here to introduce you to FaaSlang, which is an open specification for serverless functions. So what does that mean? You guys just heard a little bit about Amazon and SAM, and there's a little bit talk of an open specification there. Well, we're not operating quite on the same level, but I'll get in depth into what we're actually talking about when we say a specification for serverless functions. But to begin with, I kind of need to give you a background on StdLib and what we do, so you have an idea of the problems we're solving and how we came to this to begin with. So to start with, at StdLib, we deploy a lot of functions. You can kind of think of StdLib like NPM, almost like a package manager for functions as a service. We've managed over tens of thousands of deployments for our customers. In fact, we had so many deployments that an AWS solutions architect by the name of Paul Underwood, great guy, if you see him here in the booth, tell him I say hi as well, invited us to co-present at AWS reInvent, where we presented center stage at the Venetian Theater, essentially about the architecture that we use behind the scenes at StdLib to deploy serverless functions and actually execute them as well. So throughout this process, we kind of built this system that's a little bit complex that essentially just turns code, the code a developer writes, the functions they write, into a function as a service deployed on Lambda. And also we have this searchable library and the service registry aspect of this. So there are three main components that really a developer or a client are really going to interface with. And that's the deployment gateway, which is actually you write a function, you deploy to our deployment gateway, we format it in the way that AWS Lambda expects, et cetera. We have a service registry which says, okay, this is your service, this is the version it's available at, is this published, is this available publicly, is it only for private use? That interfaces with our searchable library, which is available on our website, StdLib.com. And we also have our execution gateway, which is when you want to execute your serverless function over HTTP, we essentially have a layer that we've built that we actually use in place of an offering like API Gateway. And then behind the scenes, obviously, we have function storage, which to begin with, and what really got us here was entirely based on AWS Lambda, which was phenomenal. So this is cool. This is our system that we kind of have built behind the scenes for really shipping serverless functions. But there's a lot of interconnected pieces, right? And we kind of own this all. Like we're this kind of vertically integrated solution where you just write a function, you type lib updev, and then it deploys for you, and it's ready, and it's documented, and it's wonderful. Fastest time to delivery of a serverless function, I believe, in the market today. You should try it yourself. But really, what do developers care about here? When we think about actually interfacing with the functions as a service that we're building? Well, function execution is really reliant on just two interfaces, right? The main interface layer is your deployment. A lot of you right now might be using something like Serverless Framework to manage your deployment to AWS or to Azure, et cetera. And then we worry about client requests. Like that could be our own clients, like a Node.js monolith that we have that's talking to some microservices, or that could be other clients, people we're servicing that want to talk to our serverless functions like over HTTP. Everything behind the scenes is kind of secondary. The number one goal, as been the kind of subject of talks you guys have been listening to here, is really shipping business value as quickly as possible and really just managing those two interfaces. Can I build a function and can I run it? So what happens behind the scenes is kind of secondary, but we want to be able to understand what's happening behind the scenes with the deployment gateway and the execution gateway. So an issue we found with our customers and with ourselves deploying tens of thousands of functions is that really every different service provider has slightly different opinions on how things should work. And like I said, there are frameworks that can manage this for you, but everybody kind of does things like a little bit differently. Are we dealing with exports.handler? Are we using the traditional Node.js, common.js module.exports? Syntax there? Do we have accessibility to the HTTP request body? What about the response? How do we manage callbacks? Are we doing something like context.done? And then on top of that, this is just like the bare bones execution level. What about things like really parameter validation, things like error handling? What about API interfaces? If you have, like, you can deploy as an HTTP endpoint, and that's fine. But then in every language that you work with, you have to set up the essentially the boilerplate HTTP code to interface with these functions. So how can we make this like super easy, no matter kind of what platform you're on, to work with? Well, because we really care about these two sections, the deployment aspect and the client request, we can really just focus on two layers here. Layer one is a deployment gateway that basically acts, you lock in as part of your infrastructure, and we have locked in as part of our infrastructure at StdLib, a deployment gateway which will automatically shim and format a lot of this stuff for you. So your developers who are actually shipping business value, they don't even have to learn about build toolchains. In fact, that's one of the biggest complaints in the JavaScript ecosystem today, in the front end and the back end ecosystem, right? Am I going to have to compile with Babel for the front end world? How do I configure Webpack? Do we want all of our developers who are just focused on adding business value thinking about these things? The answer is no, not if we can lock it in and provide real value for them immediately. So we also think about the execution gateway behind the scenes, or on the other aspect of that. Now, how do clients actually interface with these libraries or with these functions that you've built? And is there a standard way to be able to enable that? Like I mentioned on the previous slide, what about things like error handling and validation? Like what if you pass an invalid parameter? Well, if it's just a JSON object or if it's passed by HTTP query parameters, it's just a string. How do we validate that, et cetera? How do we think about those sorts of things? So this is the setup for really what FaaSlang is. And this is the layer that FaaSlang operates on. So FaaSlang, function as a service language, is an open specification that essentially just defines semantics for really deployment gateway layer and the execution gateway layer. So to put it simply, FaaSlang is an open specification, like I said, that defines semantics for function as a service or serverless, development, documentation, deployment, and execution. And that's really what FaaSlang is. So let's kind of delve into that. I've color-coded these things because I'm going to go over each one of them so you really understand what FaaSlang is as a specification. So to start with, FaaSlang is an open specification. It's available on GitHub. This is the first time this link has ever been launched publicly, so you guys are welcome to check it out. This is officially our launch, github.com/FaaSlang/FaaSlang. By open, I mean it's completely open source. We're open to any contributors that kind of want to help out and discuss the future of what these deployment and execution gateways look like. Mainly developed by myself, the founder and CEO of StdLib, also with a lot of help from Brian LaRue, who's the behind the scenes. He's given a lot of help and advice. He's the co-founder of Small Wins, also the author of the most used Slack package on NPM, and the original author of PhoneGap or Apache Cordova. And we've also been helped quite extensively by Chad Fowler, who's a divisional CTO at Microsoft, big into the microservices space, and one of the original developers of Ruby Gems. So you can see the alignment with something like StdLib and why this is so exciting. So let's talk about development. So when I say FaaSlang kind of defines semantics around development, how do we think about executing functions? Well, like I said, every single service vendor has a different opinion on really how functions should be written. We took a step back at StdLib and saw what our customers were asking for and what the confusion points were. Most of the pain points and confusion points are really around configuration. I mean, how many config files do you really need in a folder to ship something of value if it's really just a function? We've been writing functions since we started programming. I mean, arguably most of us, right? So we come from it from the perspective of functions should literally just be functions. You should write a function as if you're writing a native function in the language you're developing it for. Now, that's not entirely the case. We still need magic parameters because we still need some idea. We lose a little bit of information if we don't have like a context object. And for asynchronous execution, you still might need something like a callback. So in Node.js, this would be an example of like a Node.js function footprint. You can add as many parameters as you want, but context is like a magic parameter that gets automatically populated by the execution gateway, and callback just signifies the end of the function. With the exception of async await functions, we're adding Node 8 support very shortly, where you can actually just return a value from the function, which is very exciting. So as pointed out here, FaaSlang defines semantics for named parameters, like saying name, and default values when you're using like Node 6 or Node 7. Execution context, what that execution context looks like, what parameters it should have. That execution context should be an object that basically tells you, was this function executed over HTTP, because it doesn't need to be, but we're not just going to magically expose a rec object in the kind of global function scope there, and then the function completion callback. So that's kind of the development layer and what FaaSlang thinks about in terms of like what your function footprints look like. You're just writing actual functions. Number two is documentation. So how does your function really get documented? Well, there's already a specification that everybody pretty much uses for JavaScript documentation, ESDoc, JSDoc, that defines parameters and return values. So what part of the FaaSlang specification is basically saying any comment that you have above a function should be used to essentially inform the execution context of like what are the parameters it expects. and actually have introduced type safety mechanisms. So when you see here like param string name, your first name, and you give it a default parameter, you don't need to document this. FaaSlang actually, in our open source library, it is just a specification, but we do have working code that's fully tested. You can just define this function with the default values, and you can basically figure out what the type of each of these variables are, and then strongly type at the actual execution layer and say this should only ever be a string, this should be an object, this should be a number, etc. Or you can define that in markup. Now, what a FaaSlang deployment gateway does is basically say if you misdocument something, this documentation is one of the hardest things for developers, right? None of us want to actually fill out config files and say this is what everything does, or we do it last minute. FaaSlang won't actually let you deploy a function if there's an error in your documentation. It's going to say, no, sorry, there's a type mismatch here, or there's a definition missing. Can you please fill this out? So it encourages your team to really be standardized around the functions they're developing and be able to share those function footprints with really anybody. So from there we go to deployment. Like I just mentioned around documentation, at the deployment gateway layer, we have opinions around documentation verification. Like I said, we want to parse this function data to ensure everything is documented. There are no default value mismatches. For example, name could not equal 12 here because it expects a string. We want to make sure that there's no missing documentation, et cetera. And as a specification, and not like, this is not a framework. We do have working code that's available for you to start putting into production and connecting to your own sort of layers. But this is fully extensible because it's a specification, not a framework. So we have no opinions as to the cloud provider. Obviously, we've implemented this as a cloud provider ourselves, but if you want to run this on your own infrastructure, whether it's Google Cloud Platform, AWS, Lambda, Microsoft Azure Functions, et cetera, really any cloud provider can be swapped in, as long as you have the correct shim layers put in there to be able to interface with the functions you deploy to these services. Finally, the execution layer. Well, we have a standardized protocol for execution of these functions. All functions are invoked the exact same way. Essentially, you just pass in parameters. You can pass in an array of parameters, which will give you the parameters in order, or you can pass in named parameters, which will essentially kind of work like keyword arguments in Python, right? So all functions are invoked the same way. This is not HTTP specific, but we do have rules for if you're running this as an HTTP gateway, which is the code we provide, you should provide these error codes for these responses, et cetera. We also, on the execution level, we have built-in type safety mechanisms. So before your serverless function even ever gets executed, we check and do type safety checks to say, hey, developer, you sent us this parameter, it's a number, we want it to be a string or vice versa, can you please fix this data? And we're going to give you a client error, fix this data, and give us back what we expect so we can actually execute the function. To prevent you as a developer, your team, your development team, from having to write all of these checks or rely on external third-party frameworks, et cetera, to get this stuff done. We also provide server errors. So for example, you have to specify a return type. Here this returns a string, and if you return an invalid value, because one of your developers ships broken code, for example, any clients that are interfacing with that, they're just going to get an error and say unexpected server response, instead of getting a weird response that they weren't expecting that can put bugs in all of your client's code, right? And then the standardized protocol. So from the standardized protocol layer, we have 3 different libraries available in Node.js, Ruby, and Python. It's literally the package lib, L-I-B, on NPM, on Ruby gems, and on Python package index to interface with FaaSlang compliant gateways. So anything that follows these basic rules and follows the FaaSlang specification, you can use this lib library, specify the host name to whatever gateway that you've set up or our gateway, and interface with these functions just with one line of code. It's literally lib dot your username or your service name, and then the function name, and then you just run it literally like it's an actual function in your code. And from the type safety mechanisms, this is actually just straight out of the GitHub docs. We provide a superset, a small superset, of really JSON definitions for types. We include the integer type, the buffer type for reading raw file data, and the any type, which is just any value. So if you don't really want to obey, you don't want to use these type safety mechanisms, you can just set every variable to be any, let developers use your service or your function however they'd like. So how do you use this right now? Like how can, this is interesting, cool, type safety, this seems pretty great. Well, how can I use it today? Well, StdLib, like this is our first time announcing it ever at this conference. Currently in prototype, we have our FaaSlang compliant gateway fully built, shipped, ready to be interfaced with. So you have to install the FaaS function as a service version of the StdLib CLI tools, and you can create using the build, the -b is for build, create a service with the build FaaSlang, when you're using StdLib, and it will automatically spin this all up for you. If you want to test out the gateway on your own and see how the tests work and see how the gateway runs, you can just go to the FaaSlang repo that I linked earlier, and then just run the tests using NPM. What's really great about this too is a lot of people have talked about local execution because we've now standardized and open sourced how we expect serverless gateways to run with the specification. What you can do with StdLib and really anything that's FaaSlang compliant is local execution is a breeze because you can just run a gateway, a small version of the gateway locally that actually does all this type and error checking for you, and it's updated as part of the FaaSlang spec. So that's actually how local testing and development works with StdLib as well. You do not have to deploy your serverless functions when you're using StdLib or just FaaSlang to actually test them, which increases time to delivery in some cases by an order of magnitude when you don't have to wait to ship code every time you want to test it. So there's a lot more to come. This is the first announcement of this specification. Like I said, you can check out the GitHub repository for FaaSlang there. Our GitHub repository for StdLib and the StdLib command line tools is available as well. Follow us on Twitter at StdLibHQ, or any of you can reach out to me specifically. We also have a booth, keith@stdlib.com. We also have a booth in the pavilion. Feel free to come by and say hey and ask questions and get started. Thank you.